Hello, everyone. Very pleased to be opening this session today, and thank you all for getting up so early to attend it. We're going to be talking, obviously, about decarbonization for industry. Perhaps a round of introduction first. Philippe, you are Chief AI Officer at Schneider Electric. Could you tell us a bit more about your role?
Yeah, sure. First, thank you for being here, all of you. A few words maybe about Schneider Electric, although we're in France, a large company, Fortune 500, about 35 billion euro revenue, and we are specialized in energy management, industrial automation to help our customers be more sustainable by being more efficient. What is my role in that? Basically is how do we make sure as Chief AI Officer that we leverage AI at scale to truly impact the way we work, be more efficient, the way we serve our customers, give them a better experience, and most important of all, and we'll speak more about it today, how can we use AI to contribute to this mission of Schneider to help our customer to be more sustainable by being more efficient, leveraging AI in what we do for them to help them be more sustainable.
Wonderful. Thank you, Philippe. Over to you, Mihir. You are Head of AI and Chief AI Officer at Engie Research and Innovation. Tell us about your missions.
Thank you for having me. So at Engie Research and Innovation, I'm responsible for a program that we call Breakthrough AI, which aims to accelerate the impact of AI on the group's operations. So for that, we rely on product teams that work alongside data scientists and AI researchers with developers and designers across multiple labs around the world to develop use cases that use AI, traditional machine learning, as well as generative AI to impact all the activities of the group.
Wonderful, thank you, Mihir. And we'll end up with you, Jean-Loup. You are Chief Data and Analytics Officer at ERAMET. Tell us a little more.
Thank you. Hello, good morning, everyone. So yes, I'm in charge of data and AI for the ERAMET Group. About my background, so first I'm an aerospace engineer, then I did a few years in strategy consulting, then went back to industry through PhD for aerospace, then worked in cosmetics, and then ended up in mining, which shows that data and AI can bring you to a lot of different sectors. So I'm working at ERAMET, which is a French mining company, 5 billion euros revenue, 10,000 employees all over the world. And at ERAMET, I'm in charge of data governance, data management on one side, so being sure that we know our data assets and we control them. And then data analytics, AI, machine learning to exploit, to use this data to make smarter decisions.
Wonderful. Thank you, Jean-Loup. What I absolutely love about this panel is we know that decarbonization is heavily related to energy. And we actually have representatives of quite a lot of the energy value chain here, right? We have Engie, who are producing energy. We have Schneider Electric, who are hoping to manage that energy. And then, of course, the mining industry, quite a heavy consumer of that energy. Could you, perhaps starting with Philippe and then Mihir, tell us a little bit more about how each of your organizations are contributing actively to the energy transition? And how is AI obviously helping you with this?
Certainly. The first thing I would say, Jeremy, is when people think about energy transition and decarbonization, most of the time they think on the supply side of the equation. Fundamentally, how can we bring more renewable in the energy production mix? And that's great, and that's needed, no doubt on that. However, we in Schneider believe there is not enough effort put on the demand side of the equation, because we can really optimize the demand side to ease the energy transition. And actually, artificial intelligence has an absolute key role to play in the optimization of the demand side. So let me try to explain why AI is so important. If we want to decarbonize, there are different levers that we need to activate, and AI can contribute to many of them. The first one is super simple, but quite often we forget it. If we can use less energy for the same outcome, we're going to impact less the planet. Sounds stupid, but sometimes we forget it. And where AI can play a key role here is if you want to optimize, and use less energy for the same outcome. That outcome can be heating and cooling a beautiful room like this one. That outcome could be extracting mineral. That outcome could be managing a heating system. Any kind of outcome, you need a model. Most of the time, you cannot build a physical model. It's too expensive. Therefore, with AI, you can build a machine learning model. A room like this one, you could either build a physical model, theoretically feasible, but very difficult, or you put an intelligent thermostat that will learn from the behavior of the room and will be able to optimize the way you heat, cool, and save energy. So the first pillar, even if you use oil, gas, or whatever, if you use less of it for the same outcome, and you can leverage AI to optimize, then you generate less carbon. The second topic is, of course, it's great to use less oil, gas, and so on, but if you truly want to decarbonize, the only energy that can be fully decarbonized abundantly is electricity, obviously. And the key point is, if your electricity is produced, again, from burning oil or gas, you're back to square one. So here, AI would be super important to manage the integration of renewable everywhere. So two things to try to explain. First is maximizing the amount of green energy that you use locally. Let's take a building like this one to keep in the same idea. And let's say you want to be planet-friendly. You have installed solar panels on your roof. If you're a data center, it can be a gigantic farm of solar panels or a factory having the same, plus wind generation and so on. If you use the energy coming from this renewable, when they produce, it's great, of course. You contribute to the planet. But it's probably not optimum, because maybe when the sun is shining for you, the sun is shining for your neighbor, and the grid, electricity provided by the grid, is actually extremely green. So you don't really do much to the planet. Using AI, you're going to be able to forecast your production of your solar panels, your wind, all of that, forecast the consumption of your building, your data center, get from the grid the planification or forecast when it's going to be carbonated, not carbonated, and then optimize. And every 15 minutes, you will decide with AI if you'd better sell to the grid what you produce to help the grid be less carbonated, buy from the grid, store in your battery, use from your battery what you have stored previously, and so on, and therefore truly maximizing the contribution. And what I love in that is, and then I stop there, what I love in that is people quite often make an opposition between we can either be sustainable or be efficient. In reality, in regards to energy, if you use less energy, obviously it's cheaper and better for the planet. And obviously, if you lose, and that's less obvious, by the way, but if you maximize your green energy, that means that at the end, you avoid buying from the grid at peak of demand, because at peak of demand, the grid has to start gas-fired power stations, which are heavily carbonated, and the electric energy is expensive. So by using the solution that I was describing of optimization, you don't buy from the grid at peak of demand to avoid to buy when it's carbonated, and luckily enough, it's also when it's expensive. So I stop here, but AI is critical for the demand side of the energy transition, and without managing the demand side same time as supply side, we will not make it.
Wonderful, thanks for those insights. Mihir, do you want to jump on that as well?
Sure. So Engie is a company with a purpose, which is to accelerate the transition to a carbon neutral economy. And for that, we rely on two pillars. The first one is electrification of activities, like you mentioned. And the second one, though, is using still the molecule, gas, because some activities we know will be difficult to decarbonize and use electricity for, either for lack of raw material, for example, the lack of resources like copper. And the second thing is some activities like high temperature will still require burning gas for some time. So for that reason, we have these two pillars, and we also have flexibility management, like Philippe mentioned, as well as sobriety. So how do we consume less energy to do the same kind of activities that we do both as individuals and as industries operating on production. So for that, both in terms of sobriety and flexibility, we need AI. So I'll give you an example that leads from the example that Philippe gave in terms of the base load for energy production. So for example, now Engie has shifted to using renewables for most of its energy production, but then we still use thermal power plants to compensate when there is no wind or when there's no sun. And therefore, we switch on, switch off equipment in thermal power plants much more frequently than they were designed to do. And therefore, we have predictive maintenance algorithms that track the usage of equipment, the failure modes, so that we can predict when to replace them or maintain them. Another thing is that in terms of the purpose of Engie in its decarbonization journey, we track the financial impact as well as the ESG impact of each of the projects that we launch in terms of the investment committees. And one of the projects we have, for example, to accompany new infrastructure projects that we develop in territories is to enable the project managers and the relationship managers with a tool that analyzes the stakeholders in territories to understand how they welcome, what are their arguments for the project or against the project, what their position is, and how we can engage with them to reduce the time to market of these projects.
Yes, so that's that sounds like a great way, obviously, to ensure like a smooth transition while having a community focus. Turning to you, Jean-Loup, we know that the mining industry obviously has is quite a lot of consumption and production of emissions. Can you tell us a bit about how you're mitigating that and how AI is helping you reduce the footprint?
Sure, but before talking about that, I would like to tell that first, ERAMET is mostly part of the solution, because as you know, we are moving from, we are going through a huge transition in our energy system, as Philippe explained, from an era of consumption of fossil fuels, so gas, coal, oil, to electricity. And to do that, you need batteries. In these batteries, there are critical materials and metals such as nickel, manganese, cobalt, lithium, which are all the metals that ERAMET produces. So first, we are part of the solution. But we're also part of the problem. We emit a lot of CO2s in our processes, especially in our plants, which are very electrical intensive. So we have some projects concretely to reduce that. In New Caledonia, we have developed an AI system that at any time chooses between the best electricity source. So we have electricity from a dam that is relatively carbon-free, electricity from a solar plant that is also relatively carbon-free, and electricity from a fuel plant that is extremely CO2 intensive. So at any given time, given the amount of sun, the level of the dam, and what we forecast in terms of rains, and the needs from our furnaces, we will optimize at any time between these different energy sources to have an optimum, a financial optimum, of course, but also a carbon optimum. And both are related because our carbon has a price at ERAMET, so we add that as a cost. So that goes into what Philippe was saying. By optimizing the system, the electricity grid, we can save a lot. So it is AI systems, mostly old operation research technologies, but that works well. We also have a lot of projects on reducing the consumption on our mining equipment. You see these huge trucks that consume a large amount of fuel. Also our locomotives for the train that transport the ore from our mine to the port. To reduce the consumption, we analyze the path, how the train was driven by the driver, and we optimize the performance of the driver to say you should brake more at this moment, you should accelerate at this moment, so that we save a lot of energy. And our plants also, AI can help find better recipes in our furnaces to reduce the amount of carbon that we will consume during the process. So you see AI is all over the place. It complements all the other initiatives we have to reduce our CO2 emission, such as changing pumps or optimizing the process on the hardware, on the physical way.
Wonderful. Some super use cases, and I'm sure everyone here agrees about that. AI is all about prediction, obviously, and forecasting ability and optimize. I'm hoping all of you are fairly good at predicting. What's the next big thing in sort of where AI for decarbonization is heading? What are the next challenges you see ahead? Perhaps a short answer on that, all of you.
I would say the biggest challenge is scale. Fundamentally, we have the solutions. The question is how we can scale them and have them installed everywhere. And AI will help AI again. I think AI can play a strong role not only in those solutions that we are all describing, but also in scaling them at a lower cost by removing barriers to entry. I'll give you a very simple example. California is pushing very hard to put solar panels on the roof of every home. Okay, they have a lot of sun. What is slowing the deployment, what is the main barrier to adoption, is the lack of electricians. Because you need an electrician to come to your home. Not enough electrician, slow program. We have done a very basic AI tool where you can, by yourself, open your electrical panels, take a picture, and know if your home is fitted or not. So the next key thing for me is scale, scale, scale. AI will help, not only adoption by all of you is super important, of course. We have the solutions, we need to deploy them. And then the next thing, very shortly, more provocative, is generative AI is both wonderful. It has attracted people to AI. It has created a lot of hype. It has also opened new possibilities. It should not hide the fact that we can do a lot of things about energy, if not most of the things, without generative AI, with solutions which are more known, more robust, less energy consuming. So the next step for energy transition will not be Gen AI. It's going to be AI, but not Gen AI. That was my prediction. I could be wrong, of course.
Mihir, Jean-Loup, do you want to complete on that? What's the next big thing?
Maybe I'll jump in with maybe a more technical answer because of the lab that I'm in. So in terms of the new subjects that we're working on, we'll look at the life cycle of energy projects, from designing new power plants to optimizing operations as well as production. So for example, we're using diffusion models to analyze territories from satellite images to understand what each pixel means, if it's a natural resource, if it's a house, if it's a territory where we can install some battery storage systems, for example. We also use diffusion models to try to design new power plants. How was the optimal placement of wind turbines or solar panels on a particular site? But also digital twins. So you mentioned it earlier, but using hybrid models that use AI to complement physical models so that we can run simulations faster, so that we can optimize production faster, both for electricity generation plants as well as biogas generation plants, for example.
Thank you for that, Mihir. Super, super insightful. Jean-Loup?
So I will agree with both of you. So Gen AI and new technologies is always a challenge to put inside. But I think the scale is more important. So far, we have developed mostly AI projects that are relatively costly on very big topics. And that was necessary to do that because putting in place all the cloud technologies, AI, setting up the teams, all the data scientists takes a lot of effort and time. So you start with the big problems, and therefore you have to put a lot of money. But really, the scale is very important. So be able to replicate in an easy way one project that was successful in one plant to another one at a cost that is 10 times lower. Is really, really important, because then if we want to get all the costs, we'll have to tackle smaller and smaller projects that are more pervasive across the company. And to do that, we also need a lot of change management. Often we forget that aspect because we talk a lot about tech, but training people, so training our metallurgists, geologists, supply chain experts, all these people, we have to train them so that AI becomes one of their tool in their toolboxes, and it's not only a topic for my team, a central team with a lot of data scientists. So one of my challenges is to make sure that everyone in the company understands what it is and uses it as a tool in his toolbox. So for me, that's very important.
Very cool. We actually have a roundtable about diffusion of an AI culture and understanding coming up shortly after this. So great transition.
I didn't know, but yeah.
Exactly. Well, fantastic. Jean-Loup, you should do my job. Final question for you. We've got about 2 minutes left. AI is a bit of a double-edged sword, as we know. There's a bit of a paradox behind it. It's use AI for less impacts, but we know that AI uses a lot of energy. You need a lot of raw materials to create the things to process it. What do you think about this paradox, and how are you each acting on it? I think Philippe touched about Gen AI, so we already know that Gen AI is off the cards. Anything else to say on that?
Yeah, 2 things I would say. First, use the right tool when you do AI. Gen AI is super expensive in energy, or quite expensive. Many things can be done with traditional AI that do the job much cheaper. That's what is called frugal AI. Use AI with the right tools. Don't use a big hammer to crack a nut. The second thing is, being in AI, I love data. And I want to remind some basic data. Data centers, where all AI happens, or most of AI happens, is 1.4% of the world electricity consumption. It is 0.3% of the world energy consumption, out of which today 8% is AI. So many zeros I'm not able to remember anymore. Even if that double or triples with AI, if by using AI for the right purpose, we save of the 99.9 something % of energy use only a few percentages, the equation is good. I'm not saying that everybody will use AI and Gen AI for the right purpose. And generating movies or whatever for the internet will not help the planet. But using AI for the planet is definitely positive. And we check that in Schneider because we want to be sure. And this is not Gen AI, but for example, solution that I was describing, between the carbon emitted to run the solution and the carbon saved, the ratio, depending on the solution, is between 1 to 500 and 1 to 1,000. So AI for planet works. AI to generate dirty images don't, let's be clear.
Thank you, Philippe. Mihir, Jean-Loup?
So one of the things we've had an initiative for a few years, which is to compute the carbon emissions that result from the solutions we're building, because most of our solutions are meant to reduce the carbon emissions either for our activities or our clients' activities. And therefore, we have some sort of carbon ROI that we measure, and we hope and we expect that it's positive to continue the projects. On the other hand, to follow up on what you said, Philippe, we look at traditional AI a lot more because of the data that we process in the industry, in the energy sector and utilities, much more than generative AI, which is more functional for us, which is about improving business processes that are common to a lot of different industries, not specific to the energy sector. And however, there's one use case for Gen AI that we can leverage, which is around knowledge management. The fact that a lot of resources in power plants and sites that carry a lot of expert knowledge are going to retire in the next few years. How do we capture that knowledge? How can we use that knowledge to do root cause analysis when there's maintenance issues? How can we train new resources to come up on board? So those kind of things are generative AI can help with those things.
Jean-Loup, yeah.
I have the same thing than you. I'm also a big fan of Occam's razor principles. So try the simplest solution to tackle any problem. That's always a good thing to do. And then regarding the carbon ROI, I'm sure that our projects usually save CO2 at the end of the day, but we also want to be the best at our own activities. So clearly, we monitor all the algorithm consumption, the consumption of resources on the cloud, and we try to optimize our algorithms and the way our solutions are structured so that we minimize also our CO2 consumption. And then we also do a ROI calculation like Mihir is doing at Engie. So I think those are good solutions to reduce our own impact and have a positive contribution.
Wonderful, thank you all. We're slightly over time, but this is such an important topic that I think it's definitely worth, we spend the time talking about it. Incredibly proud to have had you all three with us to open this AI for industry on the topic of decarbonization. Let the show begin for the rest, and thank you again to our panelists. Thank you.
Thank you.